for Windows 11,
Okay.
actually Xilinx software won't support. So this is Windows 11 itself, mine also. Okay.
Okay.
So what we need to do is Oracle VM VirtualBox is there. So we need to download this. Okay. So you
Okay.
can download it from Google. I will provide you that link. Okay. So you
Okay.
need to install that. So
Okay.
after installing, so there is another thing you need to do. So you need to have the Windows 11 file. Okay. So sorry, Windows 10 file. Okay. So Windows 10 also I will give it to you. That is like ISO file, means like operating system file. Okay. So that
Okay.
file I will give you. Okay. I will tell
Okay.
you the steps also. You need to follow that steps on your laptop. Okay. So then after you can find your virtual box something like this. Okay.
Okay.
Now this is like Windows 11 లో ఇంకో Windows 10 ఉంది నా దగ్గర. ఓకేనా?
Okay, sir.
సో అలా ఆపరేటింగ్ సిస్టమ్ మనం డౌన్లోడ్ ఇంకా ఇన్స్టాల్ చేస్తాం. ఓకే. సో ఇది
Okay.
Xilinx ISC సాఫ్ట్వేర్. So this is asking for license. So for that what we need to do is just close this, close these. Okay.
Okay.
సో మన దగ్గర Xilinx ఎక్కడ ఇన్స్టాల్ ఉంది ఆ లొకేషన్ లో వెళ్ళాలి మనం. ఓకే. సో
Okay,
ఇక్కడ
sir. Okay,
zip
sir.
drive లో Xilinx అనే ఫోల్డర్ ఉంటుంది. సో 14.5 ISCTS. In that we will find ISC folder. Okay. ఆ దాంట్లో we will find a lib folder. Okay. LIB NT64. In that we need to find lib portability. So portability. So we need to find the lib portability file. You can search for here. One second. So portability.dll and .nosh is there. So these .dll file we need to do .org. Okay. And the next this one we need to change its name with .portability. That notch we need to delete it off. Okay. So
Okay.
this file, whatever we have changed, we have to copy it. Okay. So this is recording. You don't have to worry. You can find it in
Okay, sir.
YouTube also. Okay. If you are getting confused. Okay.
Okay, sir.
So in our common folder, there is a common folder. In that lib is another folder. In that NT64, we need to paste that copy. Okay. So now it's done. Now you can open it. Now again you will get like there is a license error, not license file not found. So again you need to go for here, locate existing license. Okay, fifth option, and do the next. In that you will get copy license. So this is important, means like for license purpose. Okay. So then next, wherever your Xilinx total setup file is there, so here it is there. So you need to go inside that, and there is a crack folder. You just copy that one. That's it. So license installation was successful. Now it is done. So total Xilinx software is now perfectly installed. Okay. So now this is the file. These are the menu options. Okay, what we have in Xilinx. So file, open project. So we already have our open, project. Okay. So I have given your name along with the project name. Okay. So if
Okay.
you go inside that, there is a project code or design. So there is a cyclic redundancy check CRC 8-bit. So once let us see these one. I think this is the okay. I will just take this first. So it takes some time.
Okay.
So there is a, yeah, this is the one CRC encoder and CRC decoder. Okay.
Okay.
So if you find this is very like one second, you can zoom it. Okay.
Okay.
If you are unable to see this, you can zoom it. So CRC encoder. So this is our code. Okay, this is the starting code. Okay, so which is having inputs. So what we inputs, we are having clock, reset. Okay, then next is data. So how many data bits are there? So 8 bits are there. 7 down to 0, 8 bits are there. Okay, and then next another thing, input 15 down to 0. I said polynomial. Yeah, did you remember that one? What is polynomial and all those things?
Yes, sir.
Okay, so polynomial is another input, and data is one of the input. Okay, and
Okay.
output what we get, that is CRC encoder. So whatever output we get, that is final CRC encoder. Okay, so we use a parameter called dv. So in our terms you can say division, okay, or something. Okay, so dv, here I have commented that these many times the XOR operation is done. Okay, means what is your parameter? 8. Okay, so 8 times the division method, one by one. You saw that time, like how we are going to divide. Okay, I have explained you before. Okay, so that how many times it will be done? So this is 8 times. Got it? So then next, then another thing, I'm taking count. So why I'm taking count? Because how many times it is the division process is going on, that I want to know. Okay, so with the help of this count variable, I am going to know it. Okay, so then there are some temporary polynomials, temporary variables we need to take. So according to that, one second.
Okay.
Hey, hey, चल, चला गया. So
Okay.
now but we start our actual code. Okay, so we start the logic here. Okay, so what we need to do, for every sequential logic, we need to start with the posits of clock. Okay, means there is a clock in the sense up and down pulses. Okay, so how it is, so it is like I can say you like here, where can we see clock? Otherwise I will show you at the simulation, don't worry.
Okay, sir.
This is all setup I need to do. Okay, don't worry. I will show you in the simulation what is clock. Okay, so if we are going to do the reset in the sense from the beginning the code will start. Okay, the circuit will start. Okay, so from the beginning in the sense everything becomes zero. Okay, everything becomes zero. Now then if reset condition is not applied, actual condition will take place, means the circuit will get activated. Okay, now count count is going to be increased by one. Okay, so like one after one operation, when we do one after one operation, so count is going to be increased. Then next, tempo poly is what it is doing, it is shifting by one bit. Okay, it is shifting by one bit. At that time you means might be you remember that we are like whatever the first bit was there, we are ignoring that bit. Okay, so the same method we are applying here. Okay, so what we are doing, we are just shifting it to the right side. Okay, so that's why I have taken right shifter. This is the right shifter. Okay, now if temp div, okay, div in the sense division, and temp poly, okay, temp div greater than temp poly, so then next the process starts continuing. Okay, otherwise temp div is equals to temp div, so otherwise it is idle. Okay, so then next, now if count is equals to dv in the sense how many times our operation has to be done. Okay, so here already I have given 8 times. Okay, so count is equals to dv, so then at that time we will get the reminder in the sense last code word. Okay, now whatever we get that, so the data with the reminder is called CRC encoder. Okay, so you just remember those points whatever I have given you, or otherwise again I will give you a link for the YouTube video. Okay, so you can get it from that. Okay, now what about CRC decoder, the opposite of that. Okay, so this is the CRC decoder. You can zoom it for your better visibility.
Yes, sir.
So now what you are giving input, the whatever output you got in the encoder, you are giving here input. Okay, so T input reminder. Okay, so what reminder we got from the CRC encoder. Okay, now that we are giving here, so data reminder and then next polynomial and then next at last output. Okay, CRC error, so output will find CRC error, means if there is an error or not. Then next again division 8, then next count, temp div, temp poly. Okay, so these are temporary variables. Same reset condition we apply. Reset condition, everything becomes zero, and some idle states may start. Okay, so like temp div is nothing but data plus reminder. Temp polynomial is nothing but polynomial. Okay, so then again it will start counting. So first count the process one by one, then next do the right shifting, then next find the condition temp div greater than same code. Okay, same code. Okay, simple difference is that we are taking the output of encoder into a decoder. Okay, got it? So same thing we are doing here. Okay, now at last some difference is there, like if temp div all bits are equal to 0, so then there is a no error. So if you are getting any of the non-zero bits in the temp div, so that is called we got an error in that process. Okay, so again you need to do something extra calculations for this. Okay, so but in that CRC it is not given anywhere, like what extra calculations we need to do. Okay, so but it is CRC is to find whether there is a error or whether there is a no error. Okay, that is our duty in CRC encoder. Okay, now to run this, see CRC encoder, In that below you are getting these options: design, summary, synthesize XST. Okay, in this synthesize XST, view RTL schematic. So you can see the RTL schematic for this.
ఫోన్ ఎంత వాళ్ళ ఫోన్ చేసినప్పుడు
So it is in process. It will take some time. I don't know why this getting failed. So there it is given error, missing compiler directive count is not declared. So encoder, go into the encoder. So it's done now. CRC encoder and create schematic. Now if you see, this is a block diagram. Okay. So through
Okay.
the code itself, we are getting the block diagram. You can have the snapshot of this. Okay. So 1 second, I will show you one thing. In this folder, if you go inside, you will be getting project code or design and project output screenshots. Okay.
Okay.
So you can see the screenshots here. Okay. So how we get these, I will let you know. Okay, already I have put that into folder. Okay, so you don't worry about that. Okay, just to show that, see here. Now if you double click and you need to adjust the zoom to full view. Okay, so you will be getting the actual RTL schematic for the code. Okay, got it?
Okay, sir.
So this is the means like inside how it is getting block connection. Okay, so that these RTL schematic will show. Okay, and if anyone asks you show me the RTL result, so you need to show these one. Okay, got it?
Okay, sir.
Then next we need to go for the simulation. So here there is a implementation and simulation options are there. So upside. Okay, can you see it?
Yes, sir.
Okay, so you need to go for the simulation. So CRC encoder and simulate behavior model. Now you see what polynomial we are using. Okay, see here. This is the polynomial. Okay, and this is the
Okay.
data. See, okay. Now the same thing we need to take in our simulation. Okay, I will show you again. So close this. Yes. So you need to go for the simulation. Then next simulate behavior model. So see, you will be getting the simulation window. Okay. So
Okay.
just close this middle one. Okay, and just adjust your screen. So see, first one we are having clock. Okay, so right click on that. You will be getting the option here at last force clock. Okay, in that force clock, you need to give the values leading edge value, that is 1, trailing edge value, that is 0. Okay, and your period you need to give 1 us, 1 microsecond. Okay, and apply it and click OK. Then you need to give the reset. First of all, your reset should be 1. Okay, so reset is 1. Then next, so what is your data? So force constant. Now how you get the data from? So in your base paper it is given. See, 10111101, 10111101 I can say. Okay, 001. Okay, so this is your data. Now what is your polynomial? 1, 5 zeros, then triple one. Okay, so polynomial you need to take. After that apply and click OK. Polynomial, force constant, 1, 1 2 3 4 5 zeros, triple one, and all zeros after that. Okay, so
Okay.
apply, click OK. Now these blue color, whatever blue colors are there, those are your inputs. Whatever red color are there, those are your outputs or the temporary variables. Okay, so final output is CRC encoder. Now how we will get that? So see here, there is a option called run for the time specified on the toolbar. Okay, can you see that?
Yes, sir.
Okay, so you need to press
Okay.
it for the first time. Okay, then
Okay,
next,
sir.
again another time you need to press it. Okay, now if you do the adjusting of zoom, you can see here, so there is a scrolling options also, screen scrolling options. Okay, so you need to follow those ones. Now you can see here how your clock is getting. So clock 1010. Okay, I will show you. See, clock, this is the clock signal. Okay, this is the clock signal. So clock signal will be something like this: 1 0 1 0 1 0 ఇలా clock signal ఉంటుంది. Okay, then we are having reset signal. So this is the reset signal. First of all, reset signal should be 1. Then after few clocks, 1 or 2 clocks, so it should be 0. Okay, so ఇక మనం 0 చేసేద్దాం దాన్ని. Okay, so reset force constant 0. Click OK. Then next, adjust your zoom to full view. Okay, then use the scrolling options. Okay, now if you focus here, there is a count option, CNT. Okay, right click on that and change your radix to unsigned decimal. Okay, so now it shows 0. Okay, so again run it. Okay, so count is changing. You can see here your count has changed 1. Count is 1 now. So up to what count you need to stop? So 8 counts. Okay, so 2 3 4 5 6 7 8. Okay, I have given 8 times run. Okay, see here count is getting 1 2 3 4 5 6 7 8. Got it? Then
Yes, sir.
next, after that, once you run this, you got your output. See here at last here. Okay, you got your output. See here, this is what your output is. Okay, after the 8. Okay, so actually it starts from 1 count. Okay, not from 0. Okay, so that's why 1 2 3, that will means 1 plus 8, so total becomes 9. Okay, after that 9 you will be getting the output. Okay, got it? So now these output, whatever you got, CRC encoder, you need to give these to where? So to the decoder. Okay, so how? Just see reminder. So see here reminder. What is reminder here? 0 0 1 0 0 1 0. Okay, so 8 bits are there. Okay, so it is hard to remember these reminder in these binary bits. So change the radix to hexadecimal. What is this? 26. Okay, and change the data also. Data force constant. Sorry, change the data to radix hexadecimal. So B9 and 26. These B9 26 you need to give it to decoder. Okay, now we will do it. Go for the decoder. Simulate behavior model. Same thing you need to do. One second. Anyhow, the inside screen it is showing this much itself. Okay, middle one close here. So adjust the speed, adjust it. So first of all you need to give clock, force clock. So leading edge 1, trailing edge 0, period 1 microsecond, apply. Okay, then reset, force constant First of all, reset should be 1. Then next, what is your data? Data you saw, that is B9, okay? Or in hexadecimal B9. So take the hexadecimal and B9.
B9.
9. Apply. Click OK. Okay. And then next, reminder. Reminder is 26. Okay. Force constant. You can take the option hexadecimal here. Then 26. Apply. Click OK. Then next, polynomial. What is your polynomial? Polynomial is 1, 5 zeros, triple 1, and all zeros at last. Apply. Click OK. Then next, you need to start running. Okay. So adjust your zoom. So see here, count is 0. Okay. So now after that you need to do your reset 0. Reset 0 and run. So run it for 8 to 10 times. Okay. Now you can see here your count is getting changed. Change the radix, unsigned decimal. So somewhat zoom also. Okay. See here 8. After 8, you can see CRC error. CRC error, you are getting 0 after 8. Can you see that?
Yes, sir.
So it means there is no error. Okay. So it means whatever you have given the data. So what was your get data? B9. Okay. So that data was error free. Okay. So data whatever you have given. So that was B9. Okay. So you can see here B9 was your data. So it was error free. Got it?
Got it.
In this way we need to like simulate the CRC encoder. Okay. So again, if you go inside, so CRC decoder, if you need to do the synthesize, you need to make it set as stop module. Click S. Now you will be getting the option synthesize XST. So run this. So 1 second, CRC decoder, synthesize XST, view RTL schematic. So this is CRC decoder. Okay. If you double click this, adjust the zoom. So now this is the CRC decoder RTL schematic. Okay. Now, if you see here design summary reports, there is a first option. In that you will be getting like number of slice registers, how many you have used. Okay. What was your availability for that? Okay. All these reports you will be getting here. Got it? And then
Got it.
next you are getting synthesize report. So in that, just come down. Okay. You need to scroll down, scroll down, scroll down. At last, you will be getting your nanoseconds of delay. Okay, time delay. Okay, for this circuit. Okay, got it?
Okay.
And then next, your maximum frequency, how much it has been taken. So it will show that maximum frequency also. So if anyone asks you, you can go and check here. Okay, got it?
Got it.
So this is all about the CRC encoder and decoder. So you are having any doubts?
No, sir.
So you have installed it software.
Yeah. Yes, sir.
Okay, okay. So I will give you these links. You just process on this one. Okay. So don't
Okay,
go
sir.
for that Xilinx Vivado. Let's see. Okay.
Okay, sir.
Okay then. So we will stop here. I will give you the recording. Recording has been done here.
Okay.